Quantum physics rewrites classical physics as we know it today. It teaches us something that goes beyond this world. This new science, discovered in the year 1900, has revolutionized the way scientists think. Since then, theories like Schrödinger's cat, Planck's constant, Einstein's theory of general relativity, M-theory, string theory have been made plausible. We'll be discussing wave-particle duality, which is when waves can exhibit particle-like properties, while particles can exhibit wave-like properties. For example, fundamental entities like light and electrons can behave both like a wave and a particle. A way that scientists test this is through the double-slit experiment. The double-slit experiment shows that when particles are sent through two slits, these particles can create an interference pattern, which is a series of bright and dark bands. This only happens when a scientist observes them, whereas when a scientist does not observe the particles passing through the double slits, the particles behave like particles and only go through one slit. Discussing time dilation. Time dilation is the phenomenon that time passes at a slower rate when near an object with a large gravitational field, or if an object approaches the speed of light. For example, time will move slower while near an object that has immense gravitational force. So 1 hour in stationary time could be 1 year in that object's gravitational field. If an object is traveling close to the speed of light, then the time will slow down for an object compared to stationary time. This phenomenon is closely related to Einstein's theory of general relativity and special relativity, quantum field theory, which is a theoretical theory that combines quantum mechanics and special relativity. Quantum field theory is used to describe the behavior of subatomic particles and their interactions, viewing them as quantized excitations of underlying fields that fill all of space. This theory explains localized energy packets called quanta, phenomenons such as particle creation and annihilation, as well as the interaction of energy changes, although this theory does fail to incorporate gravity. Quantum superposition is when a quantum system or particle can exist in multiple states or configurations simultaneously until it is observed. In simpler terms, it is when a particle can exist in two states, although when a measurement is made, the superposition of the particle collapses, and the particle will be found only in one state. Quantum tunneling is when a particle can penetrate an energy barrier that's higher than its own kinetic energy. In simpler terms, this means that a particle can move through an object that contains more kinetic energy than itself. Kinetic energy is the energy an object has when it is in motion. An example of quantum tunneling is a particle traveling through a door. Theoretically, in the quantum physical realm, which is the space between the electron shells of an atom, particles are capable of quantum tunneling. Seeing the Heisenberg uncertainty principle, which is a fundamental law of quantum physics and an aspect of quantum mechanics. The uncertainty principle originated from Werner Heisenberg, states that there is a limit of precision to which certain properties of particles are measured. In simpler terms, this means that scientists are not capable of measuring both the exact position and the exact momentum of a subatomic particle at the same time. The more accurate one property is known, the less accurate the other property is known. The product of this uncertainty always will succeed a particular minimum value related to Planck's constant. So theoretically, if you were to place a cat into a sealed box, you would not know if the cat is dead or alive. Therefore, the cat is in a superposition state of being both dead and alive. Applying this to a quantum phenomenon, this best explains how one particle can be in multiple states at once, called quantum superposition.